winter school. So my topic of presentation is nutrition-driven pathways to sustainable livestock production. So as you know, either in case of human being or in case of animal, nutrition is a prime importance, as we know on daily basis. So whatsoever expenditure is most we occur in terms of nutrition only. So in case of ruminant animal, it is around 60 to 65% of total livestock rearing, and in case of monogastric animal, it may goes up to 70% in case of poultry or in case of pig. So how we can sustain this livestock production through nutrition? So today we are going to discuss this one. So as per UN United Nations, what is sustainable development goals and what is sustainability? So sustainable development is development that meets the need of the present without compromising the ability of the future generation to meet their own needs. So that is sustainability. So as you know, livestock sector is a central source that generate numerous industrial activities like milk and milk products, wool, leather, meat and meat products, apparel, feed processing, vaccine and diagnostics, pharmaceuticals. And it also creates a lot of jobs, value addition, industrialization and more inclusive growth. Later in the slide, we discuss all those aspects. So as you know, today, as per 2019 livestock census, total livestock population is 535.78 million. And as you know, in our livestock rearing system, most of the rural farmers, or even in the case of urban area also, total dairy animals feed is totally depends upon the poor quality feed resources. Mainly crop residue whatsoever remaining in the village after harvesting of the crops that are offered to the animal for rearing. So it leads to the lower production of the milk. And the principal aim of livestock production is to deliver safe food for human consumption, and which is keeping the due contemplation to the animal welfare, environment, consumer mindset, and the food safety. So that is the major aim of our livestock production system. Here just I want to show the population of livestock as per 2019 census. So total livestock population is 535.78, and there is a growth of 4.63% from 2012 livestock census. Likewise, in case of poultry, there is around 17% growth in case of poultry. So we stand second in terms of cattle population, first in terms of buffalo, sheep in terms of third, and goats second. Here just we want to show the contribution of total livestock in terms of total livestock population. So different agency in India expecting different shortage of food, feeds for livestock rearing. So as per NINP Bangalore, total deficit of dry matter is 21% in 2025, 40% in case of green fodder, and 38% in case of concentrate. As per ICR, it is reported that there is 44% deficit in terms of concentrate feed, 38% deficit in terms of green fodder, and 11% in terms of dry crop residue. So there is huge shortage of feeds or fodder that will support the growing number of livestock in India. And because of that, there is imbalance in the feeding to the livestock. That will lead to the shorter lactation length and longer calving interval. There is slow growth and delayed age at first calving, shorter productive life, low milk production, lower profit to the farmer, carbon footprint is increasing, methane production, then metabolic disorder like milk fever, ketosis is also increases. That will lead to the poor growth rate and reproduction. So how we can overcome all these imbalances, that we'll discuss later on. So as per recent statistics of Animal Husbandry Department, Basic Animal Husbandry Statistics, Government of India, total milk production reaches 247.87 million tons. So there is increase in the year basis 3.58%. Per capita availability is also increased 485 gram per day. Egg production is also increases 149.11 billion number. So per capita availability of egg is also increases. 106 egg is now available per person. In terms of meat also it is increases 10.50 million tons and availability is 7.51 kg per annum. Likewise, wool is also increases. So how we can support this thing? As you know, simultaneously human population is also growing, livestock population is also growing, but per animal production is not so much growing. So how we can overcome all those things? Here is just I want to show you the contribution of total milk production of different categories of the animals, like indigenous buffalo, non-descript buffalo, goat, exotic cattle, crossbreed cattle, indigenous cattle, and non-descript cattle. Similarly, in terms of egg production, 106 is available per capita now. Here, contribution of total eggs, improved fall is contributing 86.35%, desi duck 0.85%, improved duck 0.22%. Okay. So here species-wise meat contribution in 2024 and 2025. Maximum meat is almost 50% is contributed by the poultry, rest by the different categories of the animal. So improving productivity is a huge population of low producing animal is one of the major challenges in India. So as we know, average annual milk yield of Indian cattle is only 1,172 kg, which is only about 50% of the global average. Here just a stat, New Zealand is producing per animal 3,343 kg, Australia 5,600, UK 7,100, US 9,332 kg, Israel 10,214 kg. Likewise, the meat yield of most of the species are also only 20 to 60% lower than the average. So this is the challenges that will overcome only the nutrition intervention in the livestock for sustainable production. Here is the world scenario of milk production. So why there is a low production of milk or meat in India as compared to the other nations? So there is huge population of non-descript cow breeds in India that are producing below the average level of the milk. There is simultaneously chronic shortage of the feeds and fodder, poor nutritive value of available feeds and fodder, low fertility rate, destruction of the grazing land, increasing human population, competition between the animal and man for the available feed resources. So this is the basic criteria, basic drawback. Because of that, we are not able to achieve the highest or optimum level of milk production or meat production in livestock. So how we can overcome through the nutrition intervention? Here is the different step. So by applying these steps or utilizing these steps, one or two or whatsoever suitable in that area, we can achieve or we can achieve the target or we can enhance the per animal milk production or meat production. So first criteria or first principle is balanced ration feeding to the animal. Next one is the total mixed ration or complete feed block feeding to the animal. depending upon the area or availability of the feed. Another one is the mineral mixture or area specific mineral mixture. We will discuss all these points later on. Next one is the precision feeding. So nowadays, precision feeding concepts are coming, and most of the organized farms are using this one. Another aspect is modifiers such as enzymes, prebiotic, probiotics, antibiotics, mold inhibitor, and other feed additives like herbal feed additives or herbal additives are used as a feed additive to enhance their growth rate. Another one is Azula hydroponics or seaweeds feeding that will definitely increase the production of animal by reducing their cost. Then agriculture byproducts, agriculture residue and its treatment to improve nutritive value. How we can improve that one, we will discuss later on. Then insect-based protein. Nowadays, in case of especially monogastric animal, in case of pig and poultry farming, especially in case of poultry farming, insect-based proteins are given. That are the rich source of protein that fulfill the requirement of protein in case of poultry for highest production of egg and the meat production. China already adapting this one. India is also adapting and implementing in certain area. But by growing the insect or their pupa, we directly offer to the birds or monogastric animal as a protein source. Then alternate feed resources. Apart from that, genetically modified feed resources for animals are also introducing in different countries, but India only genetically modified cotton, BT cottons are using since long back. Recently, as we all know, trade is going on between India and US. So definitely US is exporting their genetically modified crop to the India for livestock feeding. So let us see what happened in the negotiation later on. Then use of unconventional feed resources, reduction of toxicants and anti-nutritive factors, use of improved feed and feed-stuff processing technique that will lead to the better nutrient utilization. Then forage-based system, how we can feed green fodder to the animal, that we'll see later on. Then conservation of forage to support green fodder availability throughout the year during the off-season, especially in terms of hay and silages. Then reducing feed-related emission, mainly methane emission, exploiting genetic improvement in animals and feedstuff, feeding of biomass fat and protein, and last is quality control. So with this intervention, nutritional intervention, we can support for sustainable livestock production for a longer duration of time and for maximum production. So first and foremost thing is the balanced ration. As we all know, in case of human being also, balanced diet. So balanced ration is nothing whatsoever ration we provide in the 24 hours that are enough, which provide the protein, energy, minerals, vitamins from dry and green fodder, concentrate and mineral supplements in appropriate quantities to enable the animal to perform optimally and remain in healthy condition. So that is the balanced ration. So as you know, in case of balanced ration, we feed the macronutrient like carbohydrate, protein, and the fats, micronutrient like minerals, vitamin, and feed additives, as per their dietary requirements, which supply the enough nutrient for their maintenance, production, and reproduction. So that is the balanced ration. So why we go for the balanced ration feeding to the animal? So reason behind that is feeding a poor quality roughage lead to the more acetate production, which contribute to the higher methane production. So that is the wastage of energy, whatsoever we feed to the animal. So there is 2 to 15% of gross energy losses due to methane production, and that will ultimately, and that is the current buzzwords in terms of the climate change throughout the nation. So ultimately it reduced the microbial protein synthesis and reduced the growth rate and production performance of the animal. That's why we should provide the balanced ration to optimize or to overcome all these aspects of the animals to achieve the maximum production. So what is the basic necessary information for balanced ration feeding? So first and foremost thing is what is the available feed resources if you have. If you want to formulate a balanced ration in a particular area, then you must see whether it is available in that area or not. what is their nutritive value of that feeds, and what is the cost of feeds, and then nutritional requirement of animal for desired goal, like if you are preparing the balanced ration for the milking animal, for the dry animal, for growing animal, so at least you should know their nutritional requirement. Then other requirements or limitation like minimum fiber you should have during lactating animals. So it will support their production and fat percentage also. Here is the phase feeding. So after preparing balanced ration, especially in case of lactating animal, how you can offer the feed? Yeah, how we can feed the animal that will fulfill their energy requirement for optimum production. So as you know, there is different phases after the calving. So first phase is includes 10 weeks after the calving. So that will lead to the rapidly increasing milk production. But accordingly, animals are not able to eat enough dry matter that will support their production. So they draw the body reserve to maintain that production. Another phase is second phase. After 10 weeks, calving is second phase. So there is a maximum level of feed intake in this phase. Third phase is half of the lactation, last half of the lactation. So milk production is decreasing after that one. And fourth phase is dry period of 7 to 8 weeks or 10 weeks that will give the time to grow the feeding fetus and restore the body reserve. So that is the phase feeding of livestock that will essential for efficient production of the animal, especially lactating animals. Here is the timing of different feeding of foods to the animal. So dry matter is increases if you increase the number of feedings to the animal. Mainly dairy animals due to total mixed ration where all the feeds are fed together. Like hay is generally given to the animal free choice all the times. And the waste you can control by feeding smaller amounts several times. Silage once or twice a day depending upon the labor. And it is generally advisable to feed the silage after the milking only because silage have a typical smell that will catch or gain by the milk during the milking. That's why it will offer to the animal after the milking of the animal. Concentrated feeding should be done twice a day, and high producing animals should be offered concentrated feed apart from their milking parlor because that will not allow the enough time to consume the enough the concentrate within that parlor. Here is the different step of ration balancing for lactating dairy cattle. So if you want to prepare the ration, so keep in the mind that you cannot formulate the diet that can maximize the production of the milk, but formulate the diet that can efficiently produce good amount of milk and its component. So first and foremost thing is that what is the dry matter intake of the animal in question? You should calculate that one. Then second one is nutrient requirement of the animals. And third one is the amount of whatsoever available ingredient that must be fed to the animal that will fulfill their nutrition requirement within that dry matter intake limits. So this is the three basic criteria for formulation of balanced ration. Then how balanced ration impact in dairy animal? It impact on the milk yield and the milk fat. It impact on the microbial protein synthesis. It have effect on the methane emission also, immune system also, and parasitic load also. So what is the beneficial effect or benefits of feeding the balanced ration to the animals? So it definitely increase the milk yield and the fat percentage. Growth rate and reproduction also increases. Increase the lactation length and reduce the calving interval. Then reduction of the metabolic disorder like milk fever and the ketosis, because if you feed the balanced ration to the animal, it will maintain the environment of the rumen for the better metabolic protein synthesis, their absorption, and it support the high growth in young animals. Early age at calving is also increases, longer productive life is increases, there is reduce in the environmental pollution in terms of mineral loss like nitrogen and phosphorus, in terms of methane emission, that will decrease if you feed or offer the balanced ration to the animal. And ultimately, it will give to the higher profit to the farmers. Next important point is mixed ration or complete feed block. As we already discussed, mixed feed is nothing, it is just like a sani, in which you offer all those things like concentrate, dry fodder, and green fodder simultaneously to the animal. So it is a good management practices. And most important additional intake factor to consider in ration are body condition food of the animal, stage of lactation, food quality, feed protein level, method of feeding, feed access time, and diet presentation. Here just I want to show you the guideline for nutrient level in lactating dairy cow in terms of total mixed ration. So in case of early lactation, what is the different composition of the nutrients, then late lactation, mid lactation, and late lactation. Same thing here, minerals or vitamin requirements in case of lactating animals in TM. Third point is mineral mixture or area specific mineral mixture. As we all know that minerals and vitamin act as a cofactor or coenzymes that will regulate all the vital function of the body like BMR, digestion, all those things. So if any difference or deficiency or toxicity occur in the animals, that will directly affect their production system. So minerals in feeds or fodder is decreasing due to depletion of mineral from the soil. So animal gain intake of mineral directly from the feeds or fodder or water. So if any depletion in the feeds, fodder or water in terms of mineral concentration, that will directly affect the production level in the animal. So deficiency of mineral is an area specific problem. It may ranges from 20 to 70% in macro minerals like calcium and phosphorus, and deficiency lead to the effect on the growth, milk production, and pregnancy. So how it works, just I want to show here. So it directly affects the growth, health, and reproduction. Like mineral, zinc, copper, manganese, iron directly acts as a cofactor hormones like metalloenzymes that is essential for the carbohydrate, protein, fat metabolism, epithelial integrity, reproduction, immune response, oxygen transport, cell proliferation, bone development, cell protection, hemoglobin formation. And if there is any deficiency, that will limit the performance of reproductive problems, hoof and other health problems that will susceptible for the infection, slow growth rate, wound healing is slow, hair, skin feeling problem, all will occur due to deficiency of the mineral. So animal diet or feed should have enough amount of mineral in their feeds. Here just I want to show you the mineral mapping throughout the India where it is deficiency occur. So more or less each and every state having deficiency of some mineral or excess of some mineral. Accordingly, we can formulate a mineral mixture to that area that is known as area specific mineral mixture for optimum production or enhanced production to the animal. So here is the mineral deficiency in the feed stuff as per the region, like northern region having deficiency of calcium, phosphorus, magnesium, zinc, copper, manganese, and iodine. Likewise, western, southern, eastern region is also having deficiency of mineral. Here, mineral status of livestock in different agroclimatic or eco zones. So, agroeco zones like rain-fed area, irrigated area, arid region, semi-arid region, coastal region, hill and mountain region. So, more or less, there is deficiency of minerals. So, first column is showing the first limiting minerals, second column is another mineral. So mainly calcium, zinc, copper, and phosphorus is the first limiting mineral in rain-fed area. Likewise, in irrigated area, arid, semi-arid, coastal or hill region, there is deficiency in the minerals. Here is just I want to show you the requirement of that particular mineral, like calcium, phosphorus, magnesium. what cows need, like calcium 0.65 to 0.8% of total diameter intake. Likewise, other minerals are also required for optimum production. So recently, precision feeding is coming, and most of the organized farms are urban or peri-urban regions are using that one. So that one is providing the animal with feed that precisely meet its nutritional requirement for optimum productive efficiency, to produce better quality animal products, and to contribute cleaner environment and thereby ensure profitability to the farmers. So that is the precision feeding. So it is just a tool, new tool to effective utilization of available feed resources with the aim of maximizing the animal response to nutrient for economic production. So what is the different tool to achieve precision animal nutrition? First is the improved feed processing technique, how we can improve the intake of feed and their utilization. Then a strategic supplementation of critical nutrients that are deficient in that area. Then precise ration formulation, implementation of the phase feeding that we already discussed. Then use of feed additive like enzymes, prebiotics, probiotics, symbiotics, all we discuss later on. Then systematic manipulation of metabolism, like herbal feed supplements that nowadays are using for improving their absorption. So how we can improve the feed processing technique? So there are various feed processing technique that will increase the voluntary feed intake, increase their digestibility, increase availability of nutrients, remove anti-nutrition factor, increase production. So many type of treatments that are used to increase their intake and availability and digestibility, like physical treatment, chemical treatment, and microbial treatments. Another important aspect of nutritional intervention is feed additive, like enzymes, prebiotic, probiotic, symbiotic, antioxidant, mold inhibitor. So here I just want to show the classification of nutraceuticals. Nowadays, our nutraceuticals are used in case of women also. Lot of the company are coming forward, like Himalaya, then Patanjali. Likewise, in animal also, Ayurvedics are coming forward for different nutraceuticals formulation for enhancing the utilization of nutrients in inorganic mineral supplements, probiotics, prebiotics, dietary fiber, antioxidant, phytochemicals, and herbs like aloe vera, then turmeric, tulsi, thyme, sage, mint, ginger, angelina, and all are barberry, blackberry are using for nutraceuticals. Here is the prebiotic. As we know, disaccharide like lactulose, lactitol, then fructooligosaccharides, galactooligosaccharides, mannanoligosaccharides, and inulin, all are using for increasing the productivity of the animals. So what is the different characteristic feature of prebiotic? Just I want to show you here. So only inulin and fructooligosaccharides are successfully fulfill all those criteria of the prebiotic, and other are only known as possible or likely prebiotics only. Here is the different directly fed macroorganism. So different genus macroorganisms are used to increase the productivity of the animal, like lactobacillus, bifidobacterium, yeast, fungus, aspergillus, all are using for the directly fed macroorganism. Here is the different report or research that showing the advantage of using the different feed additives like monensin, live yeast, fungal culture, aspergillus, that will increase the productivity of the animals by maintaining the rumen environment. Here is the mechanism of action of the prebiotics. So either it acts as a substrate that actively participates in the metabolic reaction, or act as a cofactor in the key metabolic enzymes, or as ligands to promote or compete at cell surface, or receptor to enable better absorption or assimilation of the nutrient, or it will selectively improve the beneficial macroflora and decrease the growth of harmful or pathogenic macroflora. It eliminates the toxic principle. So likewise, they act in the animals, GIT, gastrointestinal tract, and increase the absorption. There are the different enzymes, antioxidant enzymes, and mineral involved in that one. So if you maintain that minerals in the particular required level, then definitely antioxidant status of the animal is healthy or good state that will keep animal healthy for the better performance. Here is the secondary metabolites that are present in the herbal feed additives. So here is nitrogen containing secondary product like alkaloids, nicotine, morphine, cocaine, caffeine, glucosinolates, phenolic compounds like flavonoids, anthocyanins, salicylic acid, lignin, terpenes like neonoids, saponins, and pines. So these are the secondary metabolites that are regulate or change fermentation process inside the rumen and increase the beneficial bacteria or protozoa in the rumen and decrease the methanogenic bacteria in rumen, ultimately decrease the methane production and enhance the acetate production, propionate production for efficient utilization. Next step is Azolla or hydroponics or seaweed feeding to the animal. As we know, this is nowadays are growing popular and feeding to the animal, especially a small animal, also to fulfill their protein requirements. So Azolla is very good in the protein source, 25%. Almost total ash is also 19%, 19.87% that will fulfill their mineral requirement. Then agricultural byproduct. So high we are taking precaution when feeding the byproducts. So there are various reasons behind that because it is widely varying in the nutritive composition or nutrient value. There may be chances of possible contamination in the agricultural byproducts, possible low palatability, and possible presence of the toxic substances. So be careful when feeding any new agricultural byproduct unless and until you are not knowing about that one. Another aspect is genetically modified feed resources for animals. So here just I want to show you the cultivation of genetically modified feed throughout the world. USA is having 51% cultivation area under genetic modified crop. Then Argentina, Brazil, India is only 5% in terms of mainly Bt cotton and Bt brinjal also. China 3%, other 5%, and Canada 6%. So maximum production of wheat, only soybean. Genetically modified crop is soybean, then maize, then cotton and rapeseed. Nowadays, day by day, cultivation area of genetically modified crop is increasing. So different genetically modified crop that are using nowadays is maize, wheat, sorghum, soybean, potato, cassava, tomato, cotton, canola, and alfalfa. Another aspect is nutritional intervention is reduction of toxic and anti-nutritive factor that are naturally present in the feeds, depending upon the area of cultivation. So there may be causative substances like glass, metal, plastic, and foods are present in the feed that may comes during the handling at various stages of production and processing of feeds. And then dioxins that are the contaminated mineral sources, food byproducts, fish byproducts. If you use this one in the animal feeding, that will comes under the food chain of the animal. Then various kinds of mycotoxin like alpha toxin, B1, B2, ochratoxin, zearalenone, then fumonisin, B1, like that one, because all our mycotoxin grow on the plant if higher moisture present in the plants, and then veterinary drugs residue are also present in the feeds and fodder. Then contaminants present in the feeds like our pesticides, ingredients used for the cultivation of feeds and fodder, or water contaminated with these, then definitely come into the feed chain of the animals. Then microorganisms like Brucella, Salmonella, endoparasites, ectoparasites, contaminated pasture, forage, and animal feed vegetable proteins are infested with this one. Then contaminated feed ingredient and feed water and milk with lead, mercury, cadmium, fluorine, arsenic. This is the heavy metals that are present in the industrial area mainly and mining area. And that feeds or fodder grown in that area are rich in that one. And if animal consume this one, then it will comes through the animal product also. So here is the various research that are showing the potential harmful effect of mycotoxin in animals and ultimately in human beings. So feed and food, especially milk and milk products contaminated by mycotoxin, is one of the key factors responsible for creating food insecurity. So 1/4 of the world crop is affected with mycotoxin. Remember that one. And that mycotoxin is mainly comes through the fungal growth that will produce the mycotoxin in grains. So it definitely affect the animals also and human being also. So here is a different mycotoxin that are grown on different seeds, like aflatoxin comes from Aspergillus flavus and Aspergillus parasiticus, and that are grow on cereals and cereals product, wild cakes, peanut and other nuts. Likewise, aflatoxin ye grow on wheat, barley, rye, then wheat, maize, rye. All are potentially susceptible for mycotoxin growth if there is no proper storage or high moisture present in the feeds. Here is a different mode of aflatoxin entry in human. If any contamination of the feeds and fodder, that will definitely so if any contamination or water that animal will consume, toxin goes into the tissue. So if any consumption of the meats, milk or milk products, so that will definitely comes into the animal food. So in that way, or if that food, eggs are consumed, whatsoever is the food by the human, that will directly comes into the human food chain. So here is the comparative susceptibility of different species towards the aflatoxin. So here is different higher susceptibility groups, this is rabbit, duck or swine. So LD 50 is 0.3, 0.36, 0.62. Likewise, moderately susceptible animals like horse, cows, turkeys, sheep. Then relatively resistant is chicken. So susceptibility is rabbit, duck, turkey, poultry, fish, pig, cattle, sheep. So here is the susceptibility of different species of animal towards the LD50 of mycotoxin. Here is the different effect of aflatoxin on the dairy animals, on their health, production, reproduction, and human fermentation. So in terms of health aspect, it damages the liver, major organ for aflatoxin. Then it reduces the feed consumption. It acts as a carcinogenic and teratogenic in nature, impairment of the protein formation, weight gain, and immunogenesis. Likewise, production is also reduces almost 33% decrease in the milk and reduced feed efficiency. It may lead to the mastitis. Aflatoxin M1 is secretion through the milk that will consumed by the human being. Then reproduction 120 ppb aflatoxin causes a 2% reduction in the breeding efficiency. So see the harmful effect of aflatoxin in animal. So there are various effects like carcinogenic in nature, hepatotoxic in nature, teratogenic, immunotoxic, mutagenic. Here is the maximum permissible level of aflatoxin in feeds that are depends upon the different regulating agency. So as per US FDA 2019, beef, cattle, swine or poultry having 300 ppb of level of aflatoxin that are permissible for human consumption. Dairy animal or immature animal having 20 ppb, milk and milk product having only 0.5 ppb. As per our BIS or FSSAI feeding standard, dairy animals should have 20 ppb, milk having 0.5 ppb level of aflatoxin that are permissible. As per European Union, dairy animals having only 5 ppb. So they are having very strict regulation that will control the quality of the feed to check the mycotoxin growth in the feeds and fodders. that will consumed by the animal, and ultimately their products are consumed by the human being. Here is a different aspect of good agricultural practices that will minimize the aflatoxin growth. There are some aspects of pre-harvest measurement, because ultimately whatsoever contamination or contaminant that will directly or indirectly comes from the feeds and fodder only to the animal, and that will consumed by the human being. So if we manage the pre-harvest measure of the crops, yeah, also and post-harvesting, and definitely we can minimize the growth of the aflatoxin in feed. Here is the different method that will alleviate the effect of aflatoxin. That means that will neutralize the effect. That are the some aspects like physical method, chemical method, and biological methods. So different method can use to reduce the aflatoxin level in the feeds. Then next aspect is the use of improved feed and feedstuff processing technique. Improve the utilization of the food and their absorption, like multi-nutrient block, enzyme treatment, urea ammonia treatment, reducing particle site fertilizer. So forage-based system. So we are feeding the forage, green forage or roughage to the animal that are acts as a coarse bulky feed that will fulfill their hunger. So historical adaptation to utilization of the forage nutrient remain system is developed. So there is in presence complex of 4 compartment stomach present in the ruminant animal. They are having 4 stomach. So they are all macroorganisms are symbiotically work together and utilize the coarse bulky feed for production purposes. So 65% of total expenditure on milk production attributed to feeding on milk mixed ration of concentrated and green forage is crossbreed comes through the nutrition only. 83% cost is concentrate based ration and 40% cost is green fodder based ration. So intake demand center that are present in the hypothalamus. So that will triggers the feed intake and control mechanism. And contributor to demand is body weight that are maintenance purposes, lactation purposes, conceptus purposes, pregnancy, growth, heifer or immature. So how animal meet their nutrient demands and requirements. So what is the different benefit of feeding the green forage? So it is required to maintain the normal health and reproduction of all herbivore. So overall, it has cooling effect on the body, and it is easily digestible, more palatable, slightly laxative in the nature, provide the fresh nutrient in a most natural form, resulting in efficient utilization of feed without any strain on the body organ. So that is the beneficial effect of the forage feeding. So how we can improve the feeding value of the forage? So there is a lot of variation in the feeding, variation in the nutrient content of the forage. As you know, it will depend upon the species, variety, strain of the plant. It will depend upon the different parts of the plant, like leaves or stem having the different nutrient value. Their stage of the maturity of the harvest. If you harvest in early flowering stage, their nutrition value is highest. If it is mature, then nutritive value is down. Then whatsoever fertilizer are used in the soil or their characteristic depends upon nutritive value of the forage. Then climate condition, weather, season, change during the preservation, processing, etc. All this factor directly indirectly affect the nutrient content of the feed and fodder that are grown in that particular area. So voluntary intake, another aspect of that will regulated by the both plant and animal factor, how much it will consume and how much it will utilized. So digestibility of nutrient is directly or indirectly affected by the chemical composition of the forage, their maturity stage, their form of the forage, method of processing and preservation. If you want to feed dry fodder like hay and then green fodder in terms of silage, their digestibility is different. Then a species of animal offer to the offered to the animal, then physiological condition of the animal, like animal is in either lactation stage, milking stage, then dry stage, then efficiency of utilization of digested nutrients. So forage feeding system depends on exclusive, either you let them animal free for the grazing, exclusive grazing system. Yeah, either you can use grazing supplemented with the roughage, grazing supplemented with the concentrate, stall feeding on exclusive forage like dry forage feeding only, then green forage feeding only, mixed forage feeding, stall feeding on forage and concentrate, then stall feeding of compound feeds. So these are the various system of the feeding to the animals. Then another point is conservation of forage to support green fodder availability during off season. So as we know, green fodder are not available throughout the year due to the season variation, Kharif season or Rabi season. So if any fodder are grown in that season is maximum, then you can conserve that forage in terms of the hay or silage, and that silage can provide in the off season as a green fodder to the animal. So in that way, we can use the silage feeding to the animal. So silage are more economical to use, plant with high yield of green mass production, then reduction of field losses and nutrient losses, pre-fermented feeding material that might help to mitigate enteric methane emission. So methane emission is also low if we offer the silage to the animal, because fermentation process is already occurring during the preservation process, formation process of silage. Then uniform concentrate mixture can be formulated with, then concentrate mixture ingredient can be procured for longer duration, increase in milk production of animal during dry season. So in that way, feeding of silage, you can maintain the production level of animal during the harsh condition also, that means dry season also. So assessment of crop for silage making. How you can judge the crop that are suitable for the silage making. So ideal harvesting time, like maize, it should be harvested at the time of dog stage and oat at milk stage. So how much water soluble carbohydrate is present for silage making? So it should be 3.44 gram per 100 gram of diameter. That lower buffering capacity, low protein content, that are ideal diameter content should be 30 to 40% of diameter. So this is the following criteria that will determine the crop for the suitable silage making. Then reducing feed related emission, mainly methane emission. So as we all know, we are having highest number of livestock population throughout the world, but we are not producing highest amount of milk per animal. Because of that, there is huge losses of energy in terms of methane. We already discussed that one. So there is 2 to 17% or 15% of gross energy are losses through the methane formation only, due to enteric fermentation and mishandling of the dung. So there is a share of different sector in terms of global greenhouse gas emission, and it will lead to the climate changes. So here, just we want to show that agriculture fermentation agriculture includes 50% of the methane emission. Out of 50%, enteric fermentation is 40%. Manure left or pasture is 16%. Synthetic fertilizer emission is 13%. Paddy rice is 13%, 10%. Manure management is 7%. Burning of savanna is 5%, other is 9%. So this is the contribution of greenhouse gases towards the total greenhouse gas emission. So India is only emitting 7.3%. China is almost 31%. US is 13.5%. Rest of the world is 21.7%. So India is far less producing methane than the other developed nation. So CO2 emission Per capita is very less in India, 1.7 as compared to the Middle East, 19.5, Canada 15.2, USA 14.4. Our is very less. So methane emission from Indian livestock total is 10.65 gigagram. So 10 gram. So cattle contributing 51% methane, buffalo 42%, sheep 2%, goat 4.2%, and other livestock 0.6%. So we can, if we can reduce the methane production from the animal, definitely that energy diverted to other production of animals. So different factors that influencing methane production are which type of carbohydrate offered to the animal in the diet, then rate of phase or concentrate ratio, level of feed intake, type of fat in the diet, animal species like monogastric animal or polygastric animal, that means ruminant animal, animal production level, passage rate, environmental temperature, genetic factors. So all these factors directly or indirectly govern the methane production from the animal. So available option for intervention, where we can go for intervention to reduce the methane production in rumen. Either inhibit the hydrogen formation, either reduce the hydrogen availability to the methane here, or either we inhibit the methanogens or associated protozoa number that will reduces. So methane production is ultimately reduces. So here is the different option for methane reduction like dietary manipulation, managemental practices, rumen manipulation, dietary manipulation. We can go for animal or plant breeding that will reduce less methane, rumen pH manipulation, composition of the diet, additive feed additive like fats or oil, synthetic chemicals, natural compounds, tannins, saponins, herbal sweet component. Then management, animal number, we can reduce the non-producing animal in the farms. We keep the high producing animal or cross-breeding animals. Then we can offer the good quality forage to the animal that will reduce their methane production and increase their digestibility and utilization. Then alternative livestock system efficiency we can improve. Then rumen manipulation through natural variation. Then you can go for defaunation, that means reduction of the protozoa level in the rumen. Then use of antibiotics that can particularly kill the methane producing microorganisms, especially bacteria. Then bacteriocins, vaccine, acetogens, and archaeal viruses. So these are the different options that are available to reduce the methane mitigation or production from the livestock system. Lastly, we can go for the quality control. So as you know, if quality foods are not available to the animal, then their product are also compromised with the quality, and that will ultimately affect the human. So in terms of quality control, so a lot of feed ingredients are contaminated with the different ingredients. So if we use the groundnut cake in animal feed formulation or concentrate formulation, so you can check these following ingredients, common adulterant that are maybe possible ingredient for the adulteration to make them more money. So that are suppliers are doing. So in case of groundnut, we can go for the chick of groundnut husk. They can mix urea or non-edible oil cakes. They can mix in the groundnut to increase their amount for the maximum profit gain. In case of mustard cake, you can go for the argemone Mexican acid testing. Then fibers feed ingredient or urea may be mixed. In case of soybean meal, urea, raw soybean or challah can be mixed. Dual rice bran, wheat bran, groundnut rice husk or sawdust. In case of mineral mixture, they can go for common salt, marble powder, sand, or limestone mixing to increase their volume. In case of molasses, they use the water to mix that one. Maize cob dust, and sand mixing may be possible. In rice kernel, marble grade, or may be mixed. So these are the following adulterant may be mix or present in natural ingredient, feed ingredient for maximum profit gain. So to check this adulterant, you can either go for the approximate composition of the feed, then chemical composition. It may further go for the mineral estimation, all those things, then biological estimation. All aspects are maybe used to check the adulteration. So if adulterant free feed used for the feeding to the animal, then definitely their production is enhanced and their byproduct, whatsoever milk, meat, egg, are produced that are good or suitable for the human consumption. So as we all know nowadays, lot of adulteration occur in the feed also, then their byproduct also. So as per FSSI, most of the dairy product or milk, recently news are showing, are contaminated with one or other things. So this is the last slide. So as per Varghese Kurian, 8 hours for day, 8 hours for family, and 8 hours for sleep is given by the Varghese Kurian. So thank you very much. If you have any